Alright, let's learn about covalent compounds. We have learned about ionic compounds and how to name ionic compounds. Uh, for ionic compounds, the formula is always in the simplest ratio. You know, we have to simplify the formulas. If you remember correctly, we have NaCl, you know, sodium chloride. Okay, and we have how do we come up with this formula? We have sodium plus 1, chlorine minus 1. Then we learned about polyatomic ions, sodium plus 1, SO4 minus 2, and we get Na2SO4, and we say it is sodium sulfate. So there are polyatomic ions. So then we learned about Roman numerals. Okay, lead 4 oxide. That means I have Pb plus 4, oxygen minus 2. So I get Pb2O4, and I simplify it. So the formula is PbO2. This is lead 4 oxide. So we learned about Roman numerals. We learned about polyatomic ions. We learned about simple compounds. But this story is much different and easier. For covalent compounds, the compounds are formed between nonmetals. Okay, so first of all, you need to know when is it covalent compound. So if you know the periodic table, you have nonmetals on this side of the periodic table. So if both elements are from this side, we have carbon, oxygen, nitrogen, phosphorus, chlorine, chlorine. If both elements are from this side, that means it's a covalent compound. And for covalent compounds, they're found by the sharing of electrons, not a transfer of electrons. So it's not that sodium is going to lose an electron, chlorine is going to gain an electron. There is no loss or gain. They share. Okay. So to name that, the first element is named first. There is no positive, no negative, and the second element will turn into IDE, just like we learned before. And we will use prefixes to show the number of atoms. So you have carbon, and then you have one oxygen. So you will say carbon monoxide. So the prefix for the one, where is it? Prefix for the one is, prefix for the one is mono, prefix for the two is di, tri, tetra, penta, hexa, hepta, octa, nana, and deca. So these are the prefixes we are going to use. Okay, you have to memorize it. Mono means 1, okay, di means 2, tri is 3, tetra is 4. So if I have CO2, so I have 2 oxygen atoms, so I will say carbon dioxide. If I have 1 oxygen atom, I will say carbon monoxide. I don't use one mono for the first element. Do not use it for the first element. So it will never be monocarbon monoxide. We will just say carbon monoxide, carbon dioxide. If I have P2O4, so now I have 2 phosphorus, so I will say diphosphorus, and 4 oxygens, so I will say tetroxide. Okay, so we are going to use prefixes to show the number of atoms. There is no crisscross at all. Okay, we will just keep it as it is. So this is the easiest method you will learn of naming compounds, and it is so easy that once you learn it, you start using it across the board. So please pay attention that you're not going to do that. You're only going to use it for covalent compounds when both elements are non-metals. That's the only time you're going to use this. So let's do some practice on this. So I have 6 borons. 6 means hexa. So I will say hexa boron, okay, and 1 silicon monosilicide, because I need to turn this into IDE, hexaboron monosilicide. Then I have carbon monoxide. So I have to mention the number of atoms for the second element, even if it is 1 or 10. Okay, but for the first element, I don't use mono. For the second element, I have to use it no matter what it is. Now I have 4 phosphorus atoms. So I will say tetraphosphorus, and then I have 5 sulfur atoms. Pentasulfide. And writing the formula is even easier. There is no crisscross. I write as I read. I have 2 nitrogens. So I'll say 2 nitrogens and 2 tetroxide. Tetra means 4 oxygens. Then I have phosphorus, just phosphorus. So I write phosphorus. Trichloride means Cl3. So dinitrogen tetroxide or phosphorus trichloride. So this is how you name the compound. So go ahead and complete the practice, and we will do it in the class. So that's all about naming compounds for covalent compounds. Let's talk about properties of covalent compounds. Covalent compounds are made of two nonmetals. Okay, they share electrons. There is no transfer of electrons like ionic compounds. They share electrons. Okay, so the bonds are weaker than the ionic compounds. If the bonds are weaker, they have low melting point and low boiling point, and they tend to be gases at room temperature, and they do not conduct electricity in water. So these are the properties of ionic compounds. You should be able to compare the covalent and ionic compounds. Like ionic compounds are electrolytes in solutions. Covalent compounds are not electrolyte in solutions. You see, they're opposite to each other. These are electrolytes, these are non-electrolytes. They are transfer. The ionic compounds are found by the transfer of electrons. Like sodium has one, and chlorine has 7 valence electrons. So sodium will transfer one of its electron to chlorine. So this becomes -1. This becomes +1. So this is a transfer of electrons. Whereas covalent compounds are formed by the sharing of electrons. So you have to understand the difference. High melting and boiling point, whereas they have low melting and boiling point. They are brittle solids, and these are usually gases at room temperature. Okay, I don't know where that is. These are gases at room temperature. So ionic compounds are solids, these are gases. Sometimes use Roman numerals. They don't use Roman numerals at all. They are easily soluble in water. Okay, these are non-soluble in water. So you must understand the difference. Easily soluble in water, ionic compounds, they're non-soluble in water. We use formula units here, and here we use molecules. Okay, so make sure you understand that. For ionic compounds, we use formula units. For covalent compounds, we use molecules. Solid at room temperature, these are gases at room temperature. Okay, as I was saying here, sometimes use Roman numerals, never use Roman numerals. Okay, separate into ions, they do not separate into ions. Formula units must be reduced, no formula units at all for covalent compounds. Do not use prefixes, whereas covalent compounds use prefixes. Okay, so there are a lot of, everything is kind of opposite, everything is different for covalent compounds versus ionic compounds. So you should be able to know the difference of covalent and ionic compounds. You should be able to know what is a covalent compound. It is formed by the sharing of electrons between two nonmetals, and how to name compounds and how to write formulas. So I believe that's all for covalent compounds I need to know. And then next you need to do the mixed naming practice, and we will do that in the class.